about two very important forces acting on an object that is already in uniform circular motion or any kind of circular motion. The first force that we shall talk about is known as centripetal force. Definition of centripetal force: a force which keeps a body moving with a uniform speed along a circular path and directed along the radius towards the center is called centripetal force. So if you look in this diagram, there is an object that is moving in uniform circular motion. You can see the direction of force is shown inwards. So the force that is acting towards the center of the circle is known as centripetal force. The equation for centripetal force is F is equal to mv square upon r. We are supposed to remember this equation, and this equation gives the magnitude of centripetal force. So centripetal force F is equal to m into v square upon r, where m is the mass of the object, v is the speed of the object, and r is the radius of the circular path in which the object is moving. The best example to understand centripetal force is a stone tied at the end of a string. Suppose you tie a stone to the end of a string and you start whirling it. That is, you start moving it in a circle. The necessary centripetal force for this circular motion of the stone is provided by the tension in the string. And that tension in the string is acting towards the center of the circular path. Now, a very quick tip. If there is a question based on centripetal force anytime, either in board questions or any test you are writing, it is important to mention where is the centripetal force coming from and what is the direction of centripetal force. For example, there can be a question about rotation of planets around the sun. So the planets are in a circular motion, so obviously there is some centripetal force acting on the planets. Where does the centripetal force come from? That centripetal force for the planets acting on the planets is provided by the gravitational force of sun, and the direction of that centripetal force is always towards the center of the circle, that is in the direction of the sun. So anytime you are explaining an example for centripetal force or centrifugal force, the other force that we are going to talk about, it is very necessary to mention where is the centripetal force coming from or where is the centrifugal force going and what are the directions of both the forces. So that was all about centrifugal force. We should remember that a uniform circular motion is not possible without centripetal force. That means if there is an object that is moving in a circle, there is definitely some centripetal force acting on it, because circular motion is not possible without centripetal force. The other force that acts on an object in circular motion is centrifugal force. Now we should remember that when we use the word petal, the centripetal force acts towards the center, while centrifugal goes away from the center. Now this is an apparent force, it is not an actual force. Please remember, actual force acting on the object is centripetal force, while an apparent force is also known as pseudo force. So centrifugal force is a pseudo force which draws a rotating body away from the center of the rotation. It is caused by the inertia of the body as the body's path is continuously changing. Also remember a very important fact about centripetal force and centrifugal force. Both of them are not a pair of action and reaction forces. This is a very common misconception. Students think that centripetal and centrifugal forces are action and reaction forces. Totally wrong. No. Centrifugal force is not a reaction force, but centrifugal force is caused due to the inertia of the body because the body's path is continuously changing. So again, if we come back to the example of a stone that is tied and that is whirled around, then if we talk about centrifugal force in the example of whirling a string tied to a stone, the centrifugal force acts opposite to the tension produced in the string. It will always be in the opposite direction of the tension that is produced in the string. We are supposed to remember that. So centripetal towards the center, centrifugal away from the center. A little more in detail about centrifugal force. Centrifugal force is in the opposite direction to the direction of centripetal force, but it is not the force of reaction of centripetal force. Please remember that it is not the force of reaction of centripetal force. Important to understand that. Also, a centrifugal force is not a real force, but it is a fictitious force, or it is also known as a virtual force, or it is also known as a pseudo force. Because it is an apparent force, it is not an actual force. Absolutely important to remember all these things. So next we come to the quick revision of the chapter. Whatever we studied in this chapter. First thing, we had to talk about force. A push or a pull which changes the state of rest or of uniform motion or the direction of motion of a body is called force. Definition of rigid body. A rigid body is the one whose size and shape remains same whatever the force we applied to different parts of it. So a little more about rigid body since we didn't talk in the beginning. Remember, practically no body is a rigid body. Because whenever a force is applied on a rigid body, although its shape and size may not change, but it may break under the action of a very, very high force. So practically, rigid bodies are not possible. Still, however, some hard objects like metal, stone, glass can be considered bodies in physics. Next, a force that can rotate an object is called a turning force. Remember, an object can be rotated only when it is pivoted at a point. We had a talk about this in the first lecture. Those who have not seen the first lecture, please go back to the first video where we have talked about turning forces. So, a turning force acts on an object only when it is pivoted at a point. Pivot is also known as fulcrum. It is also known as turning point. So whenever turning forces are acting on the body, we calculate something that is known as torque or moment of force. So torque or moment of force is given by the equation torque is equal to force into perpendicular distance. Remember, torque is a vector quantity and its SI unit is Newton meter, while its CGS unit will be dyne centimeter. That was all about a single force acting. Now, if there is a pair of equal and opposite forces acting on an object, then it is said to constitute a couple. Now, whenever there are two forces acting, we calculate moment of couple, which is given by the equation. Moment of couple, that is MOC, is equal to magnitude of either force. Remember, whenever we are calculating numericals, we should take only single force, any one force, because both the forces are equal. So magnitude of either force into perpendicular distance between the forces. That was all about moment of force and moment of couple. Now when an object is rotating, it may rotate either clockwise or anti-clockwise. And for an object to be in equilibrium, there is something which is known as principle of moment that should be obeyed. So principle of moment is given by sum of anti-clockwise moments is equal to sum of clockwise moments. This is a principle that is we are going to majorly apply when we do the numericals from the next class onwards. So the total sum of all the anti-clockwise moments should be equal to total sum of all the clockwise moments. Now when we say sum, that means there can be a number of forces acting on the left hand side there can be a number of forces acting on the right hand side. The sum total of all the forces, moment of forces on the left hand side should be equal to sum total of all the moment of forces on the right hand side. Next, we come to center of gravity. Center of gravity is generally known as the balancing point of the object. So, definition, it says that the center of gravity of a body is a point which algebraic sum of moments of weights of all the particles of the body is zero. The sum total of either all the forces acting on the body or all the moment of forces acting on the body should be equal to zero. Then only the object will be balanced. And the point at which the object is balanced is known as its center of gravity. We had also done about center of gravities or different shapes of objects in the second video. Next, uniform circular motion. We also have talked about uniform circular motion in the second video. When a body moves with a constant speed in a circular path, then its motion is known as uniform circular motion. Remember, in uniform circular motion, the speed is constant while the velocity is variable because the direction of motion is changing at every point. Hence, we say that uniform circular motion is an accelerated motion. Next, when we talk about circular motion, we talk about the two forces that we just studied. Centripetal force. The force that maintains the uniform circular motion of an object is called centripetal force, and it is directed towards the center of the circle. While the apparent force or fictitious force or pseudo force or virtual force that draws the rotating body away from the center of rotation is called centrifugal force. It is a pseudo force. There are many questions asked based on centripetal force and centrifugal force. There are many examples given where you are supposed to explain where is the centripetal force, where is the centrifugal force. So it is very important for us to remember in terms of direction, both of them are opposite, but in terms of magnitude, both of them are equal. We just studied that the equation for centripetal force is F is equal to mv square upon r. I'll show you once again here. Equation for centripetal force is F is equal to mv square upon r. So the equation for centrifugal force is also the same. F is equal to mv square upon r, but with a minus sign, since centrifugal force is opposite to the centripetal force. Here we come to the end of our theory. I'm leaving a link below in the description box for you people to be able to ask me questions. Any doubt, any question in the theory of the chapter, please shoot me an email and I shall reply to you personally.